Good morning. Today we'll be starting off with the most important chapter of chemistry. It's organic chemistry. This comprises the largest portion on the syllabus and is the most frequently tested thing on the paper as well. So now in organic chemistry, first we'll talk about the classification of organic chemistry. All substances which contain carbon, hydrogen, and oxygen atoms are known as organic compounds because they are present in the nature. Now, there are four types of organic compounds: alkanes, alkenes, alcohols, and organic acids. Each of them can be characterized by their own functional group. For example, the alkenes can be simply recognized by a single bond between the carbon-carbon. Alkenes can be recognized by a double bond, alcohols by an OH group, and organic acids with a C double bond OH group. Now we'll talk about some of the important properties, the physical as well as the chemical properties of organic compounds. We know that by using fractional distillation, we can easily separate the different types of constituents of petroleum so they can be used for their specific purposes. For example, they've talked about naphtha, which is used for in the petrochemical industry as well as for medicines, plastics, and synthetic fibers. Now, the difference between a saturated and unsaturated carbon is that an unsaturated carbon has a carbon-carbon double bond, and usually unsaturated hydrocarbons have a lower melting and boiling point than saturated hydrocarbons. So now we'll talk about alkanes. Their chemical formula is CnH2n plus 2. The principal four types of alkanes are methane, ethane, propane, and butane. Meth means 1, eth means 2, prop means 3, and but means 4. So you calculate the chemical formula of each of the following. Now we need to know the physical as well as the chemical trends. This is for how butane is represented in the diagram. You can see that each carbon has a valency of 4, so it can pair up with 4 atoms. It makes 3 hydrogen bonds and pairs up with the other carbon atom. Now, the important physical properties are that the boiling points increase as we get down the chain. For example, butane has a greater boiling point as is visible in the table as well than methane. Also, that alcohol, the important property is that they are insoluble in water. However, they are soluble in other organic solvents such as ether. They, I've already talked about how their melting and boiling points increase. Now, related to this is another physical property that why their melting and boil points increase. Obviously, because their size increase, and as their size increase, they become more viscous in nature and they increase in viscosity as well as the density, which increases. Now, as if a substance has a greater boiling point, it becomes less and less flammable because it becomes lesser volatile in nature. If we talk about the chemical reactivity of alkenes, alkanes are mainly chemically inert. However, the only predominant reaction which we can see is combustion, in which alkenes react with oxygen to release carbon dioxide and water. There are two types of combustion: complete and incomplete combustion. Complete combustion occurs in the presence of oxygen, whereas incomplete combustion occurs when there isn't any suitable amount of oxygen present in the environment. So there is unburnt carbon and carbon monoxide being released. Similarly, in the reaction with chlorine, halides are formed, and this is known as a substitution reaction, in which a chlorine atom gets attached to the hydrogen, and you can see this is substitution reaction. The important factor which is mandatory for the reaction to proceed is the presence of UV light. Now we come to the other organic compound. These are alkenes. Alkenes have a carbon-carbon double bond between them, and this is their chemical formula in which the number of hydrogen atoms are always double the amount of carbon atoms. Now, the unlike alkenes, alkenes have both many chemical as well as physical properties. The important ones are similar to alkanes, they undergo combustion reaction, but the most important one is the addition reaction. Addition reaction is in which either, for example, ethene reacts with hydrogen or bromine. The hydrogen atoms selectively attach across the double bond in at the two carbon atoms. So you can see that after the reaction, the alkene is converted into an alkane, and there are all single bonds present only. Now, the important distinguishing thing which separates it from all other organic compounds is the bromine test. Whenever you add bromine, we know that bromine has a reddish brown color. However, on addition to ethene, what happens is that bromine loses its reddish brown color and it becomes colorless. Now, apart from bromine, there water can be also attached, and whatever is attached is across the double bond. You can see the addition of water. They can in the exam they can tell you how ethanol can be made from ethene. So you should know that ethene reacts with water to form ethanol. Now, as I told you above as well, it will be talking about the physical properties as well. The physical properties are like the alkenes at their boiling points also increase down the crop. Now, the important use in everyday life is the manufacture of margarine. The all the polyunsaturated means that the multiple double bonds. So now the food containing multiple double bonds is reduced to produce margarine. Here we can see how apart this is vegetable oil, and upon addition with hydrogen, it gets broken down into margarine molecule. Vegetable oil is unsaturated, whereas margarine is saturated in nature. Now, we talk about the cracking of alkanes. We know that crack alkanes are extremely large in molecular size. So what we do for industries is that we break them down into shorter chains so they can be effectively used in a wide variety of industrial applications. This is repeatedly tested in the exam. This property is known as cracking. I've talked about isomers in the past papers I've done in the videos. However, I'll just tell you that what are isomers? Isomers are molecules of the same substance which have the same molecular formula, but they have a different structural formula. And by the different structural formula, I mean that they have a different number on the side chain. I'll talk about all these examples in detail later, but now I'll have a preference to cover the syllabus rapidly. Now we talk about alcohols. The major reaction of alcohols is fermentation reaction in which ethanol is made by yeast. What happens is that ethanol, you can see that glucose is used to make ethanol and carbon dioxide by yeast, and the important temperature requirements must be kept into account as well. The temperature is kept constant at 37 degrees centigrade. Similar to this, now we talked in the reaction of alkenes, how alkene is reacted with water to form ethanol. And the uses of alcohol are that alcohol is used as an organic solvent and as a preservative as well. Some of the reactions are common to all of the four functional groups, such as combustion, also oxidation. Now, oxidation is the gain of oxygen atoms. So when we react ethanol with oxygen, it forms ethanoic acid. And you can see ethanoic acid is also referred to as acetic acid or vinegar. Now there will come reaction between ethanol and acids really makes an esters, and the major use of esters is in perfumes. Then we come to the last functional group, and these are the carboxylic acids. Now, unlike the usual acids such as sulfuric acids or HCl, most important characteristic of carboxylic acids are that they are extremely weak acids. Okay, and now why a substance is a strong acid or a weak acid? A strong acid is known as such because it fully dissociates in water. However, a weak acid only partially dissociates in water, leaves only some hydrogen ions. Now we talk acids react with bases to form a salt and water. This is known as the neutralization reaction. And whenever you're told to construct an ionic equation, you should know that the ionic equation will be H plus to denote the acid plus OH minus to denote the base, which gives you a salt and water. Now, there are several properties of acids. We know that they react with bases, I've discussed now, and they react with metals to form a salt and a hydrogen gas. This hydrogen gas gives effervescence in the form of rising bubbles. Also, in the case of carbonates and bicarbonates, for example, give you chemical reaction and tell you to guess the byproducts. So you should know that whenever you react an acid with the carbonate or bicarbonate, carbon dioxide and water are released as the byproducts. And in an ester, I've already talked in the past prepared videos that basically water is the byproduct, and what happens is that the OH molecule is taken out from the acid group, whereas the hydrogen molecule is taken out from the alcohol. And the catalyst used, you need to memorize that H2SO4 sulfuric acid is used as the catalyst, and this is always a reversible reaction. Now we come to the last part of the topic, that is polymers. What polymerization is that we combine many monomers, and monomer is a basic structural and functional unit. So in order to make macromolecules, many monomers are combined, and after combining them, they make a polymer, and a polymer can contain as many as thousands of monomers. Now, the thing to distinguish monomers is that they all contain carbon-carbon double bonds, whereas after addition, the polymer is represented by a single bond. And if you look closely, this symbol N represents or denotes that if there are a very large number of molecules, and the repeating unit which is being repeated in the polymer several times is known as the repeating unit. Now there are two types of main polymers. Firstly, there's a condensation polymer in which there's a loss of water, and the principal type of example is terylene, in which you need to remember that there's a carboxylic acid and a diol. Diol and dicarboxylic acid means that you can see there are two functional groups of carboxylic acids and two functional groups of hydroxyl ions. Now, in the case of nylon, there is an acid and an amide. They combine, which is reduced from here, and hydrogen is released from here. So the C double bond O NH combine. And nylon has many industrial applications as well. It is used in stockings and in the parachutes and used in garments to give them strength as well. So these are pretty much of the artificial polymers, and polyester is also a condensation polymer. The natural macromolecules in our everyday lives are carbohydrates, proteins, and fats. Proteins are made up of repeating amino acids. Similarly, carbohydrates are comprised of mainly glucose, whereas fats are comprised of many fatty acids and glycerol, which combine to form esters. I hope you like the video. Thank you.